this is still on? You're still here? Well, you want to hack something? So today we're taking on my friend and business partner, Husky Hack's latest TryHackMe room, Weasel. I know it's been in review for a long time, it just dropped this week, and I can't wait to take a crack at it. I also think it involves some technologies that I'm pretty familiar with, so I'm excited to get started. I have the TryHackMe room up and running. I have an IP address, and of course, I'm connected to the TryHackMe VPN. We're going to start with some basic discovery, and the way that I like to do that is with rust scan. So we're going to run sudo rust scan, and let's just modify our commands so that they match. We're going to run rust scan, and what are we going to do? We're going to modify this IP address. And we're also going to make sure that we hit everything. You know, Husky can be sneaky. So we're going to do range 1 through 65535 to hit all of our ports and make sure that we put that in the right option flag. So we'll do that there, and then -A for the address. I'm using -B with a batch of 200s just so I don't overload anything, but if you want to go faster with rust scan, you can. What rust scan does, if you're not familiar, is that it will do a quick TCP hit on every port and then pass the open ports over to Nmap to do any further investigation. So that's exactly what we're going to do. We're going to do a quick knock on every one of these ports with rust scan and then do a full SYN scan with full fingerprinting on those open ports, and we're going to save that as plaintext to nmap.txt. So let's let that run. Okay, before we even get to the Nmap part of this, I can see we have some pretty interesting ports. We have 22 SSH, and then we have our normal Windows stuff, 135 and 139 for RPC and CIFS. We have 445 for SMB. We have 3389, that's remote desktop. 5985, that's going to be Windows Remote Management or WinRM. And then the quad 8, which I think I know what it is, but I want to test it to be sure. I have a feeling that quad 8 is going to be Jupyter, because that's sort of what this thing is going to be all about. In fact, even the description of TryHackMe's Weasel says, I think the data science team has been a bit fast and loose with their project resources. So data science to me says Jupyter Lab, Jupyter Notebook. And so by default, that service runs on quad 8s. So that's kind of what my guess is, but we're going to confirm it. If you're not familiar with scanning Windows devices, you might take a look at these high port numbers and raise an eyebrow. They're not weird. They're actually totally normal. Those high TCP ports are part of normal Windows host-to-host, peer-to-peer communication. They use arbitrary high TCP port numbers in the 40s to 50s to make that happen. Okay, our Nmap is finished. Let's take a look at what Nmap has for us. So let's see, we have port 22, OpenSSH for Windows. All right, so that's cool. Windows can do SSH. In fact, I use that all the time. And we had every other reason to believe this was a Windows machine with our RPC and CIFS stuff. RDP, we do get a host name here, dev data sci jup, or yup if it's a soft J. And of course we have 445. Where are you? There you are. Nothing interesting here, but we'll do some further enumeration on our SMB. And then on quad 8, sure enough, there's Jupyter Notebook. So we'll take a look at that quickly as well. And then we get to those high TCP ports for MSRPC, not too worried about those. So two big findings here. We have the SMB and we have the Jupyter Notebook. So I'm going to start with the SMB server because it's a Windows machine and that's just kind of muscle memory. Now, we don't have a username or anything for our SMB server, so what we're hoping is that there is an unprotected SMB share that allows anonymous read. So we're going to use SMB client to take a look at that. Let's just go ahead and use SMB client -L and use the IP address without any slashes or anything when we just do the listing for the shares. SMB client -L, and then we don't have to pass in any additional information, right? Because if it allows access like this, we should just let it enumerate here. And indeed it does. Now, this doesn't tell us what we can and can't read. We can use other tools to make that happen, like crackmap exec is really good for that, but I like using SMB client just for a first pass. Now that I have my share listings, what do we have? So admin, of course, and C. Odds are that we're not going to be able to do anything with those, especially without creds. IPC, same deal. But this data side team, that's pretty interesting that I was even able to see that. So my next move is to go with SMB client, and instead of -L, we're going to use //. Now, a lot of times people will tell you to use 4 backslashes, which works because you're doing // and then you're escaping those, and so it becomes / 4 times. But it turns out that SMB client also will accept 2 // and I find that a lot more ergonomic. And then a single / for the share name. Let's paste that in there, and let's see if we can connect. Awesome. Looks like we can. Now that we are connected over SMB, let's just run dir to see what we have in here. Oh boy, we have quite a lot. We have IPNYB checkpoints. We have a lot of data about weasels. We've got a miss folder, papers, pics, requirements.txt, a weasel.ipynb, and a weasel.txt. All right, let's go ahead and get everything. So to do that, I'm going to do recurse on and mget star. And just go yes, yes. We have now gotten everything off of this SMB share. So what do we have? We have, of course, the Jupyter notebook here, IPYNB. We also have a couple of folders. Let's take a look at the contents of miscellaneous. There's a Jupyter token, which is weird. We have some papers. We have some pics. And all of this might be valuable. But the one that jumps out at me is absolutely the Jupyter token. Let's find out why. So we've now fully enumerated our SMB server. Let's go take a look at that quad 8 and see what's going on there. To do that, we're going to just navigate to it in our web browser. HTTP that, and we'll give it quad 8. Okay, so the way that Jupyter Notebook works is that it generates a unique token for every session. And if you run it locally, then it kind of puts that at the end of the URL for you when you launch it. But if you try to access it without that, you can either attempt to set up password authentication or it will ask you for a token. Luckily, we were given a token. So if we cat out the misc Jupyter token, we'll copy that over here, paste that right in. And we're in. All right, so what do we have going on? We're looking at a running Jupyter notebook, and we're looking at essentially the same directory that we saw in the SMB share, including the weasel.ipynb. Now, I could have used Jupyter Notebook or Jupyter Lab to launch that thing locally, but because I knew it was running remotely on this server, I figured let's just get there. Let's double click on this and take a look at this notebook. Okay, so we have some data science work about weasels. Now, unfortunately, this is just straight up Jupyter Notebook, not Jupyter Lab, so I can't change it to dark mode, but we'll live with it for now. Not a whole lot of interest here, but that's okay, because it turns out the Jupyter Notebook has another capability. If we go back to our homepage here, it was easy to miss, but there is another capability we have. If we click on new, oh look, we can make just a terminal session. Well, that's handy. What is going on? We have launched a terminal session for the hosting computer here, but look at what's going on. We were told that we are in a Windows computer, we are attacking a Windows computer, but this appears to be Ubuntu 2004. Notice that it's Microsoft, though. So one of the things that you could probably guess at as to what might be happening is that we're looking at a Windows subsystem for Linux situation. And that's exactly what I think is happening here. If we run uname-a, again, we see that Microsoft. This is WSL, which means that we are still on a Windows machine, but we're inside of the Windows subsystem for Linux. That could be good news, that could be bad news, depending on what we want to do. Let's see who we are, first of all. Who am I? We're dev data sci, okay. And where are we? We're in home dev data sci. Let's just do a quick listing, see everything that we have here. Bash history, blah, 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 blah. Oh, interesting, sudo as admin successful. The very presence of this file tells us that this user has some sudo privs. So we're going to get there in just a second. What else do we have here? There is this file at the end here, dev datasci low priv id ed25519. Let us cat that out. Oh, interesting. It's an SSH private key. Now, I'll take that. Thank you very much. I'll just copy that right off of the terminal here. And I'm going to save that in a private key here. We'll call that dev datasci.key. Yep, paste that right in. Now, of course, remember to use SSH keys in Linux. If you're using Kali like me, we have to change the mode to 0400 so that it is read-only. Okay. So the first thing we might try to do is use this SSH key against the Windows machine that we know has an SSH server running. What username would we use? We'll start with dev datasci. Let's go ahead and do that. So SSH dev datasci, nope, sorry, SSH-I to use our dev datasci.key, and then dev datasci at, let me go copy that IP address again. Yes, I do want to add that, but that seems to be wrong. We don't have the right user, or the key is incorrect, something else is going on. So there was actually some valuable information inside of the Jupyter notebook. If we look carefully, you'll see that there's an error here based on one of the libraries that the notebook was loading, and it gives us another user, home Husky. If we look at the home folders inside of WSL, we don't see that. That's kind of weird. So we might attempt to use Husky as another username to enumerate. So if we want to go hard mode, we can do something like crackmap exec to brute force some usernames and passwords. Let's see what that would look like. So over in this window, I'm going to run crackmap exec, or CME. We're going to do it in SMB mode. And we're going to give it our IP address, a username of Husky, and a password file of documents, seclists, passwords, leaked databases, rocku.txt. We're not going to work too hard here. And let's just see what we can see here. Well, that didn't take long at all. Thank you very much, Husky. I appreciate you not making that too difficult. We did indeed find that there is a user named Husky with a password of 123456 on this machine. So right away, we know that WinRM was open, so we might try something like evil WinRM, right? And we might try something like here. This is some old stuff. I honestly don't remember what CTF this is from. And we'll try username of Husky and the password of 123456 just to see if this user is in the WinRM group. Odds are not. And in fact, there's a faster way to find that out over in crackmap exec. Instead of running our password enumeration as we just did, we'll give it just a straight up 123456, and we'll look for -- shares. This will tell us what Husky can do really on the machine. WinRM just failed, and then of course, let's take a look at what we have here. So Husky has read-write to the data science team, but notice that Husky doesn't have read-write or anything to admin or C. This is the hint that you're not going to be able to do much of anything because Husky's not a local admin on this machine. If Husky were a local admin, you'd see read-write here for admin and C. It just doesn't exist here, so unfortunately, Husky's not really going to be a way in for that specific vector. But what we can do is another trick with crackmap exec, which is brute forcing the RIDs. The RID, or relative ID, is the last part of a Windows SID, or security ID. It's going to look something like 500 if it's an administrator, or 1000 or north of 1000 if it's a regular user. And by brute forcing those numbers, we're able to enumerate users with crackmap exec. All we need is a single account that's authenticated to the machine over SMB, and we can do this RID brute trick. It's really, really handy. Okay, that worked a treat. We can see that we actually do have another user here, dev datasci-lowpriv, so it's a similar but different username than what we had before. What we might try then is our SSH again, but with the username dev datasci-lowpriv. And we're in. I'm going to change this over to a PowerShell prompt just so I don't lose my mind. And let's go into our desktop. And let's do an ls. There's our user.txt. Let's go ahead and cat that out. Beautiful. We'll add that. Now for root. There was one path that we haven't yet explored, which is back over in our Jupyter notebook right here, our prompt. We never found out what this user could do with sudo. Let's find out with sudo-l. Oh, so interesting. So we have some no password options, which is exactly what we want to see as an attacker. We have su dev datasci-c. That's pretty weird. And I don't necessarily want to mess with this too much, but this is very interesting to me. If I can run Jupyter as root, I may be able to elevate my privileges a bit. And why that matters is if I ls-al/mnt, this is some Windows stuff. So Windows Subsystem for Linux hosts the Windows file system for itself at /mnt/c. But as you can see, it's owned by root. I'm unfortunately not able to see much past this. Kind of a pain. Now, if I become root, that may be able to change. So if I run another instance of Jupyter on another port, I may be able to elevate my privs. So how does that look? Let's first see if we actually have Jupyter in local bin. We do not. But what we do have is a folder called Anaconda 3. So if you're not familiar, Anaconda is an alternative package manager for Python. It's very data science specific, and you can use Conda instead of pip. It works great if you are a data scientist. I've used Conda in my classes before. Anyway, let's take a look inside there. We look inside Anaconda 3. There's a bin folder that will include Jupyter. So pretty hacky, but what we can do is cp Anaconda 3 bin Jupyter over to .local bin. And now we have created a path that matches what we have in sudo-l. Now, this may or may not work depending on what command you use. This, I think, is going to work out okay, but we're going to give it a shot. So the first thing we're going to do is sudo. So the first thing we're going to do is sudo local bin Jupyter, and let's just run help just to see that it runs itself. All right, fantastic. It does. We're going to do Jupyter and then lab, because I want the lab. And we also want -- help for that. There's going to be a lot of help for that. Awesome. Looking good. So let's see. I want to launch it on another port. So we'll do 8889. And the IP is where it's going to be advertising. And by default, it's going to be localhost. So we need to change the IP and the port. I think that's pretty much it. So sudo Jupyter lab -- IP 10.10.110.0 and -- port 8889. Okay, so, oh, it says running as root is not recommended. Use allow root to bypass. You got it. Allow root. Okay, I'm gonna helpfully just click on this right here. And we've opened up Jupyter Lab. This might take a second to load, but it is loading. And since we're using Jupyter Lab, what a relief. Now from here, we can just open a terminal right here in a launcher. Zoom that in a bit. Now I'm root not in Windows necessarily, but in Windows Subsystem for Linux. Okay, so what I would normally expect from here is to ls/mnt and see, and should be able to see stuff, but it's not there, weirdly. That's pretty weird. If we take a look at mount, it's missing. That's bizarre. But since we're already root, we should be able to do something about that. A quick search for mounting Windows file systems in WSL brings up this really nice answer. Thank you very much, Stack Overflow, with mount-t dirvfs, and then the server name, if it's a server name, and then to wherever we're trying to put it. But because, again, there's this interesting interplay between Windows Subsystem for Linux and Windows, we actually have the ability to do the drive letter as well. So what we'll do here is we will mount-t drvfs c, capital C, to mount C. Now, if we do ls mntc, hey, look, we actually have the C drive mounted. Now, if we ls mount C users, you'll see that we're getting permission denied here for the default user and all users because those symbolic links are not available, but we are able to see everything else, including administrator, desktop. And there's the root flag. Elevated Weasel. Longest boy. Thanks very much. So that is one way to achieve root on this box, but I know for a fact that Husky has left us plenty of Easter eggs and other methods of privilege escalation, including one that may involve installer packages. And I leave that as an exercise for you to try to find out for yourself. So that's going to do it for this video walkthrough of Weasel. I hope you enjoyed it. I hope you enjoy the box. So until next time, be good to yourselves, be good to each other, and happy hacking. We'll see you next time.